Hi friends, in this lecture we are starting with vectorial representation of complex number. We will consider various graphic representations for complex numbers like equation of line, equation of a circle in complex plane, and similarly equation of parabola, hyperbola, ellipse, etc. So this is the most important topic of complex variable for IIT JEE. So please pay due attention. It is a bit long lecture, so please bear with me. So what is a vectorial representation of a complex number? Every complex number can be considered as the position vector of that point. So suppose z is a complex number represented by the point P, then z can be said to represent OP, this line. If z1 is the complex number, so z1 can be said to be representing OQ here. So what is the direction of OP? OP direction is this one, and this is the direction of complex variable z. Suppose we have minus z, then this would be the direction would be other way round. And what is the modulus? Modulus of OP is equal to modulus of z, which is r in this case. So can we just represent a complex number by position vector, or does it follow the laws of addition and subtraction as well? Now consider this point P1, x1 represented by x1 and y1, and P2 represented by x2 plus y2. Now if we draw the parallelogram with this as these two as coterminous sides, then what do we get? OP1 P P2. Now let us consider the vector OP. This is as in geometry and in vector algebra, this is sum of OP and OP1 and P1P. It is OP. Now let us see whether this is equal to OP and plus P1 as well. Now what are the coordinates of P? It is this x coordinate would be this distance if we draw vertical, and what is this one? It is this distance plus this distance, and this distance is the x2 coordinate of P2. So it is x1 plus x2. And similarly, this if we say that P1 is y1, so this distance is y2, so this distance is y1 plus y2. So the coordinates of P are x1 plus x2 comma y1 plus y2. Similarly, when we go for this minus z, z2, so this minus z2 is minus x2 minus y2, so we draw it backwards and we reach here, and we draw complete this particular parallelogram OPQ P2 dash. So this point is x1 the minus x2 and y1 minus y2. Now OQ and P2P are parallel, so this length and opposite side of a parallelogram, so OQ would be equal to P2 P1 here. So this distance would be also be equal to x1 minus x2 comma y1 minus y2. So P1 P2 would represent modulus of z1 minus z2. Now here this is written wrongly. OP is not equal to P2 P1. It is P2 P1 is equal to modulus of z1 minus z2. It is OQ. OQ is equal to P2 P1 is equal to modulus of z1 minus z2. Now let us consider the triangle inequality. We know that as per triangle inequality, sum of two sides, that is OP and OP1 and P1P, is always greater than the third side, length of the third side, which is OP in this case. So OP1 plus OP2 would be greater than equal to OP. Now if we look at this particular triangle OP1 P2, now in this triangle the two sides are OP1 and OP2, so their sum is also greater than or equal to P2 P1. and P2 P1 is nothing but Z2 minus Z1. So OP1 plus OP2 is going to be greater than over OP or P1 P2. Now we also know that any side is always greater than or equal to the difference of other two sides. Now again, if we see that in this triangle OP P1, and we say that this is the side OP, ठीक है, OP is greater than OP1 minus OP2, the difference of two other side, OP1 minus OP2. And if we look at this particular triangle, we say that this particular P1 P2, that is modulus of Z1 minus Z2, is also greater than equal to difference of the two side, that is OP1 minus OP2. So we get this from triangle inequality, and from this we can simply write that modulus of, if we replace OP1, the value is here, then OP1 is modulus of Z1, OP2 is modulus of Z2. So we put it here, and P1 P2 is modulus of Z1 plus Z2, and OP is equal to modulus of Z1 plus Z2, and P1 P2 is modulus of Z1 minus Z2. So we get this triangle inequality, that modulus of Z1 plus minus Z2, whether it is plus or minus, it is always greater than equal to the difference of modulus of the two numbers, that is modulus of Z1 minus Z2 whole modulus, and it is also less than equal to modulus of Z1 plus modulus of Z2. Now in exam you will get two type of question. One which would say that find the maximum value of modulus of Z1 plus minus Z2, or the other would say find the minimum value. So for maximum value of this expression, we will have to use the right hand side of equality. So if say modulus of Z1 plus minus Z2 is always less than equal to 3, then the maximum value it can attain is 3. Similarly, if it is greater than equal to 2, then the minimum value it can attain is 2. So we have to just keep this thing in mind, that for less than getting the maximum value, we would use this portion of the inequality, and for getting the minimum value we will use the left hand side portion. It is obvious, but in exam if you don't remember it specifically, you may commit some error. No need to take notes for this lecture. This whole lecture along with all the examples which we are covering in this video is available at Exxamm.com/12391. Now let us discuss centroid, incenter, orthocenter and circumcenter of a triangle on a complex plane. What does it mean? That we have to find these points for a triangle whose vertices are given as Z1, Z2 and Z3. Now let us first take the case of centroid. Centroid, we know that centroid would be Z1 plus Z2 plus Z3 upon 3. Why I said we know? Because if we remember from coordinate geometry, the centroid with respect to a triangle ABC, whose coordinates were x1, y1, x2, y2 plus and x3, y3. The centroid was x1 plus x2 plus x3 divided by 3, and y1 plus y2 plus y3 upon 3. So in this case also we have got the similar formation, that centroid of G is equal to z1 plus z2 plus z3 divided by 3. So rather than having 2 points x and y, we have just got one formula, that centroid is equal to this much. Now what would be the coordinates of incenter? Incenter in case of coordinate geometry were ax1 plus bx2 plus cx3 divided by a plus b plus c, and similarly for y coordinates, here a, b, c are the length of the triangles, sides of triangle. A is the length of the side opposite angle point A, So A is BC and B is equal to this particular line, and B is the line opposite point B, and C is the length opposite point C. So in center is this, but this formula you would rarely get a question which would ask you to put values in the formula, as has been the trend in JEE. Now what is the coordinate of circumcenter? Circumcenter is here. Now circumcenter is a point which is equidistant from the three other points of the three other vertices of the triangle. Now if Z0 is the circumcenter, then Z modulus of Z0 minus Z1 is equal to modulus of Z0 minus Z2 is equal to modulus of Z0 minus Z3. It is the center of a circle which passes through ABC, and its encircles it from outside like this. Like this, it circles this is the circle. Then the center is called the circumcenter. In center is the circle which is inside this, like this. So this is the that it would be the in center, and circumcenter again is the center of a circle which passes through all the three vertices like this. Unlike incenter, circumcenter is very important in case of complex numbers, because let us suppose if it is given that modulus of Z1 is equal to modulus of Z2 is equal to modulus of Z3, then if this particular point becomes origin. So in that case, always remember, whenever it is given that modulus of Z1 is equal to modulus of Z2 is equal to modulus of Z3, that is Z0 is equal to 0, then the origin is the circumcenter. So using this property, there are large number of questions which have come in the JEE. Now let us see the relationship between circumcenter, orthocenter, incenter and centroid. We will start from the coordinate geometry and use the same relationships in our lecture number 12420, which is available at Exxamm.com/12420, which covers all these points with respect to coordinate geometry. We know that for any triangle, centroid, orthocenter and circumcenter are collinear, and centroid divides orthocenter and circumcenter in the ratio 2:1. That is, centroid is nearer to circumcenter and farther from orthocenter and in between. So this distance, when it is x, and this distance would be 2x. So one property of circumcenter, we said that if modulus of Z1 is equal to modulus of Z2 is equal to modulus of Z3, then in that case circumcenter is origin. And this is the second very important property, and we have to remember that centroid is nearer to circumcenter. So if this distance is x, then this distance is 2x. So, or if this distance is x, then distance between circumcenter and orthocenter is 3x. So there will be question mixing the two facts, and where circumcenter would be usually origin, and then orthocenter would be 3x. So keep in mind. Now if the triangle is isosceles, then in that case on this Euler line itself, incenter would also lie on this Euler's line. And last and the most important fact is that we have read that in case of equilateral triangles, centroid, circumcenter, orthocenter and incenter, all the 4 points coincides. So the question in exam would come where we are asked to find the incenter, and we are just thinking about which formula to use, or in case of orthocenter, are we supposed to use a complex formula? So the chances are quite high that the triangle will turn out to be an equilateral triangle, and we would have to just find centroid, which is z1 plus z2 plus z3 is divided by 3, and which would be orthocenter and center and circumcenter would be have the same point as their centroid. So now coming complex plane, now let us find the equation of a straight line with the help of rotation formula. So in rotation formula, let us say that z is a variable point and z1 and z2 are the fixed points, and we have to find the locus of z which moves such that it always lies on the line joining A and B. So what do we know from our rotation formula? That in this case the value of argument of z minus z1 upon z2 minus z1 would be either 0 or we can say it is pi. So if we what does it mean? That if a argument of a complex number is 0 or pi, then in that case that number is purely real. When it is purely real, it's number that complex number, which in this case is z minus z1 upon z2 minus z1. Then this, if this number is purely real, then it would be equal to its modulus. Say suppose this number was equal to alpha plus I beta. Since it is purely real, then its conjugate is alpha minus I beta, so it would be, and if it is equal to its conjugate, then it would be, what would it mean? Beta is equal to 0, that is alpha, this complex number is purely real. Just recalling the facts which we have already told, that whenever a complex number is purely real, it is equal to conjugate of its conjugate. So we get the equation as z minus z1 upon z2 minus z1 is equal to the conjugate of this whole number. Now conjugate is distributed over division as well as addition or subtraction. So we distribute it accordingly. We get this is equal to z bar minus z1 bar upon z2 minus z1 bar. Now this is the equation of a straight line. Now let us consider the case and find out what is the condition for which two lines are parallel. So in this case the process would be same, that we would use the rotation formula and say that this angle between this line and this line is same. So what would the rotation formula look like in case of two parallel lines? That argument of z1 minus z2, that is z1 minus z2, is equal to argument of z3 divided by argument of z1 minus z2 divided by z3 minus z4 is equal to 0 or pi. So it means again that this is purely real, and if it is purely real, then this would be equal to its conjugate. So writing like this as we have done just now, so it is z1 minus z2 upon z3 minus z4 is equal to z1 bar minus z2 bar upon z3 bar minus z4 bar. This is the condition for parallelity between two lines whose points are given as z1 z2 on one line and z3 z4 on another line. Now conditions for which two lines which are perpendicular, what is the conditions for two lines to be perpendicular? It is that the argument of z1 minus z2 upon z3 minus z4 would be pi by 2. So argument of z1 minus z2 upon z3 minus z4 is equal to pi by 2 or minus pi by 2 if we go anti-clockwise in this case. So when is this case true? When they are purely, numbers are purely imaginary. When they are purely imaginary, then what is the condition? Then sum of the complex number with its conjugate is equal to 0. So if earlier it was equal, now it is equal to minus of its conjugate. So it is z1 minus z2 upon z3 minus z4 is equal to minus bracket z1 bar minus z2 bar upon z3 bar minus z4. This way we get condition for two lines to be perpendicular when 2 points on each line are given in complex plane. Now what is the general equation of a line in complex plane? General equation of a line in complex plane is given by this formula. Here it is a bar z plus a z bar plus b. Now is equal to 0. Now z we know, that is representing x plus iy, and it is the equation of the line is the locus of z. So here we have to remember that a is a complex number but b is a real number. Suppose in some case b is instead of b it is given as 2i, then in that case we would multiply or divide the whole equation by I, so that this particular number becomes the real number. We can always convert it into real number b as real number by multiplying or dividing by I. Well, if it is b instead of b instead of I or 2i it is given as 3 plus 4i, then we would divide the whole thing or multiply the whole thing by the conjugate of that number, so that this becomes real. Then only we can derive various formulas and values for this particular. Now what was the equation of general equation of a straight line? In case of coordinate geometry it was ax plus by plus c is equal to 0. So what has happened? A has become a bar, b has become a, and c has become b, and x has been replaced with z and y has been replaced with z bar. So this equation I want you to remember. The best way to remember is to do so many problems of a particular thing which you have to remember, that it or you remember it automatically. Now here, what is the complex slope of a line? This is very important again, that complex slope of a line is minus a upon a bar. Now the rules for complex slope of a line are a bit different than in the case of normal slope of a line. In case of normal slope of a line, which I would explain to you in a short while. Now we know that the complex slope of a line is minus a upon a bar. Then what is the equation of a line passing through z1 and z2? And what is the complex slope of a line passing through the a that is z1 and b that is z2? It would be given by the omega. It is called omega. Omega is used to represent complex number in many cases, a general complex number. So just don't jump to the conclusion that omega is one of the imaginary cube roots of the unity. It is just another way to denote a complex number rather than z. So omega is equal to z1 minus z2 upon z1 bar minus z2 bar. In case of coordinate geometry it was y2 minus y1 upon x2 minus x1, but here in this case it is z1 minus z2 upon z1 bar minus z2. So complex slope of a line making an angle theta from positive axis, you can easily check, is equal to e to the power I to theta. I am not going into details of this, but you can easily check that this complex slope of this line making an angle theta from positive axis is e to the power I 2 theta, but you should remember this particular fact. If omega 1 and omega 2 be the complex slope of two lines, then what is the condition of parallelity between these two lines? That their complex slope should be equal. So omega 1 should be equal to omega 2 when lines are parallel. But then here comes the difference. In case of m1 and m2 being the slope of a line, the condition of perpendicularity was m1 m2 is equal to minus 1. But in case of complex slopes this is not the case, but the condition of perpendicularity is omega 1 plus omega 2 is equal to 0. So please keep this thing in mind. There may be a question, this is an important topic, and in exam you may get a straightforward question using this this particular portion of the this particular portion of the condition. Now I am going to tell you the parametric form of a equation of a straight line. Now parametric form of the equation is z is equal to 1 minus t multiplied by z1 plus t z1. This is the equation of a line passing through point z1 and z2. Now what is the role of t? If z is lies on the point on the line joining z1 and z2 as is required for this to be a straight line, then in that case z would be dividing z1 and z2 in the ratio of t with 1 minus t, where t is less than 0 to 1 to get the equation. This is the way to get. So this, by this method you can remember, and you can remember the equation, parametric form of equation of a straight line, and also remember the significance of t and the fact that t has to lie between 0 and 1. So here z is equal to 1 minus t multiplied by z1 plus t into z2. Our next point is reflection points for a line. If a point is given like P and we have to find reflection of this point against a particular line whose equation in complex form is given to us, then we have to find the coordinates of Q and value of Z2, where this is the mirror image of point P, image of a point in a line. Now as we are seeing that I am not giving many examples at this stage because many of these examples on this topic would be using more than one topic. So as of now I am just explaining the basic concepts, and these are very simple concepts based on coordinate geometry. So I am not giving examples at this stage, but at the end of this lecture I will give you so many examples, because this portion of complex variable is so important that we have to do large number of questions. I will personally explain quite a few examples where these concepts with the help of examples, but also give you a lot of quizzes and daily practice problem to be done by you. See, our endeavor is to give you complete information, be it a video lecture, be it examples and other problems which we explain through the video, and they then give you practice problems with solutions so that you can check solutions, and so that your coverage is complete. At the end of that, we will also give you previous year JEE's problem, last 38 years whatever problems in complex variable have come, we will give you solution of those problems also, and you can try them on your own. But if you are not able to do that, go through the solution provided by us. Now in case of a straight line, first, what is the general equation of a straight line? It was alpha bar z plus alpha z bar plus r, where alpha is a complex constant and r is a real number. So we can write that if 2 points P and Q denoted by complex numbers z1 and z2 respectively are the reflection point against this line, then their middle point would lie on this particular line, and this line A would be the right bisector of point P and line joining P and Q because of the property of mirror image. So this particular line, the line becomes the perpendicular bisector if Q is the mirror image of the point P here. Now let the equation of the line is given as alpha bar z plus alpha z bar plus r. Again, alpha is a complex constant and r is a real number. even so, in case where instead of r some complex number is given, we have to divide this whole equation by that complex number, so that we get the value in this equation in proper format. Then only we can apply various formulas which we have learned. So now I have said that this middle point would, because this is perpendicular, this line is perpendicular bisector, and Q is the mirror image of P. So the middle point of this, that would be Z1 plus Z2 upon 2, would lie on this complex equation of the line. So let us put this this thing in on our equation, and what do we get? Alpha bar, instead of z, we put z1 plus z2 by 2 plus alpha, z1 bar plus z2 bar divided by 2 plus r is equal to 0, and on solving, this is the equation we get. Alpha bar z1 plus alpha bar z2 plus alpha z1 bar plus alpha z2 bar plus 2r is equal to 0. Now we have two conditions. So we to solve this equation and to remove the unwanted variable, unwanted constants, we have to use another condition to our advantage. That condition is that this line is perpendicular to this is being a perpendicular bisector, would mean that middle point of PQ would lie on this line, and second point is that this line is perpendicular to this particular line. Now what is the complex slope of this line? It is z1 minus z2 upon z1 minus z2 bar. And what is the complex slope of this line? It is, as per the formula, minus alpha upon alpha bar. But these two lines being perpendicular, the condition in case of complex slope is omega 1 plus omega 2 is equal to 0. So in that we put a value of omega 1 and omega 2, and we get this equation. So by solving these two equations, the final answer we get is this, that alpha z1 bar plus alpha z2 alpha bar z2 plus r is equal to 0. So if we have this equation of this is given and coordinates of z1 are given, then we can find the value of z2, or in any other permutation or combination. But we know that if z1 and z2 is the mirror image of z1 with respect to the line alpha bar z plus alpha z bar plus r, where r is a real number and alpha is a complex constant, then in that case alpha z1 bar plus alpha bar z2 plus r is equal to 0. We will do example of this also. Now let us find out the distance of a particular point from a line. So what do we need? We need the coordinates of the point, and then we need the equation of line, and we have to find this particular distance. Now in case of coordinate geometry, if we had to find the distance of point x1 y1 with respect to point a with respect to line ax plus by plus c is equal to 0, then the perpendicular distance between them was ax1 plus by1 plus c divided by root of a square plus b square, and the quantity on top was taken, a modulus of the ax1 plus by1 plus c was taken, because the distance is always going to be positive. So here also we will, this is the equation of the line, and by using putting the value of zc as equal to xc plus ic and doing the manipulations, we will finally get a similar result here also, that is zca plus zc bar a plus b divided by 2a. So you can go through this solution at our notes Exxamm.com/12391. These are simple calculations. I am not going into that because this topic is anyway very big. So go through this if you want to check the solution of this. Otherwise, remember this thing that we in the equation we have just put the value instead of zc, as we did in case of coordinate geometry. It is modulus of zc a bar plus zc bar a plus b modulus divided by 2a. Now let us take a very simple example in which we will be putting the values in the formula, but it would reinforce our understanding of this particular formula. That is the distance between point and a line. We know it is a bar if the equation of line is a bar z plus a z bar plus b, and the coordinate of points are say z2, then in that case we have to just put the value of z2 here instead of z and take modulus and divided it by 2 of alpha. Now in this equation, what is the value of alpha bar? Just before we start, we see that this is 2i, and we have mentioned time and again that this should be real. So what do? We divide it by 1i. So it becomes 1 upon I, 1 plus I divided by I z and 1 minus I divided by I z bar plus 2 is equal to 0. So then we have the equation in proper format, and here our alpha bar is equal to 1 minus I divided by I. So how do we move ahead? We just put the value here. A is equal to root 2, a modulus of alpha is equal to root 2, and we just take the modulus of this equation, that is 1 minus I, 2i plus 1 plus I minus 2i plus 2, and we get the answer as 3 by root 2. This is a straightforward example. Such questions don't come in JEE, but we are just doing it for the sake of understanding the concept. Now our next topic is very important. It is different forms of equation of circle. Just a small concept I wanted to explain to you. Now in this first equation is obviously of the circle with origin as center of the circle. So in this case this equation would be modulus of z is equal to r, because for all points on this circle the modulus of z is equal to z minus o is 0, so z minus 0, this distance is z minus 0, so its modulus is modulus of z minus 0, that is modulus of z, and this is constant because it is the radius of the circle. So the first equation is modulus of z is equal to r. It represents the circle whose center is origin and whose radius is r. Now second question comes, second is modulus of z minus z0 is equal to r. Now in this case consider a circle whose center is z0, so and the point, any point on the circle is z. So when this particular distance PC is equal to modulus of z minus z0, and it is constant for all values of z around the circle. So this equation becomes modulus of z minus z0 is equal to r. Now this is very important equation, and it has many usages, and questions based on this have come frequently in the past in IIT JEE. So please remember this, that modulus of z minus z0 is equal to r. So what does this means? Like if suppose z0 is equal to 3 plus 4i, then how do we write this equation as modulus of z minus 3 minus 4i is equal to r. So then we are given that modulus of z minus 3 minus 4i is equal to say 5. Then what does it mean? That this would be equation of a circle with center 3 comma 4 and radius 5. So this we have to remember, very important equation, and I will be giving you many examples based on this. If you put z is equal to x plus iy and z0 is equal to p minus p plus iq, and then we will get the equation as x minus p whole square plus y minus q whole square is equal to r square. Now here r is the radius. Now unlike coordinate geometry, if modulus of z minus z0 is equal to r, then r itself is the radius and not root r. Keep this thing in mind. Now what was the general equation of straight line? It was a z bar plus a bar z plus b, where b was real number. I cannot emphasize any more the importance of b being real here. Now if in this, if we add z bar, then what do we get? We get modulus of z square, which is nothing but x square plus y square, and this is equation of a straight line. So this is equivalent to plus 2gx plus fy plus c is equal to 0. So if in the equation of a straight line a z bar plus a bar z plus b is equal to 0, we add z bar, then we get the equation of circle. Now what is the equation of this? What is the center of this particular circle? It would be minus a, and here a is a complex variable and its radius is equal to root of modulus of a square minus a. This would be the radius, our radius. We will do examples on that which will enhance your understanding. Now equation of the circle with center z0 and radius r is equal to modulus of z minus z0 is equal to r. We can expand it by squaring it and then writing this as its multiplication of this complex number as with its conjugate. So we get z minus z0 bracket z bar minus z0, and on expanding it we get z bar minus z bar 0 minus z bar 0 plus z square, z0 square minus r square is equal to 0. When we compare this equation with this equation, what do we get? That z0 is nothing, minus of z0 is nothing but a. So center becomes minus of a. Z0 was our center, so center becomes minus of a, and modulus of z0 square minus r square is equal to b here. So r is modulus of z0 square minus b square under square root. So our this equation becomes r square, r is equal to modulus under root of modulus of z0 square minus b. Now here in this case, what do we know? That z0 is equal to minus of a. So replacing that we get root of root of modulus of a square minus b. Please note that we have done some typo here, and here it should be b. So root of modulus of a square minus b, that is the correct answer for radius. Now let us take a very simple problem, that if z is a complex number, then locus of z satisfying the condition 2z modulus of 2z minus 1 is equal to z minus 1 is, whether it is a circle, parabola or perpendicular bisector of joining 1 by 2 point, 1 by 2 and 1. Now here I would like to explain this point in a bit of detail. If let me activate my pen. Okay, here it is. Z minus Z1 divided by Z minus Z2 modulus here as well as here, if this is equal to say 3, then this would always be representing a circle. Why? Because if we take modulus of Z minus Z1 and take modulus of Z minus Z2 and replace Z with X minus X plus Iy, then what would we get? X minus X1 whole square plus Y minus Y1 whole square is equal to 9X minus X2 whole square plus Y minus Y2 whole square. So this would give us the value 8x square plus y square. Now when we have 8x square plus 8y square plus some expression of in terms of x plus y, some say ax plus by is plus c is equal to 0, then what are we getting? We are getting that the coefficients of x square and y square are same, and there is no term we having x y in the common, and there is a second degree equation. So this would represent our equation of a circle in all case. Whatever be the value here, it would represent, except when this value is when it is equal to 1. When it is equal to 1, this would reduce, this x square and y squares will cancel out, and then what we have left with modulus of z minus z1 is equal to, it is a bit difficult for me to write with this particular pen, so bear with me with my handwriting here. Modulus of z minus modulus of z2. Now what does it mean? That z is equidistant from z1 and z2. So in that particular case, this, suppose z1, this is z2, and say this is z1, and z is equidistant, so that this distance is equal to this, and when z is going in such a way that this distance is equal to this, so what is the z, where would z lie? Z would lie on the perpendicular bisector of the line joining z1 and z2 if modulus of z minus z1 is equal to modulus of z minus z2. So this is very important, and we will have many application of this in various examples. The minute we say that, say modulus of z minus 2 is equal to modulus of z plus 2. If we say here, say modulus of z minus 2 is equal to modulus of z plus 2, then in that case, where would z lie? Z would lie on the perpendicular bisector of the line joining 2. This is 2, point 2, and this is point minus 2. So minus 2 and 2 line joining its perpendicular bisector is nothing but the y-axis. So when we say z plus I is equal to a modulus of z minus minus I, then the minus I, then in that case where would z lie? Z would lie on the line joining perpendicular bisector of the line joining minus I and plus I. In that case, perpendicular bisector of the point line joining minus I, and I would be our x-axis, like this. So here this is minus I, this is, sorry, I, and this point is I, and this point here is minus I. So the perpendicular bisector is, this is the perpendicular bisector, and this would be the x-axis. Now coming back to our original equations, what do we have here? Here we have modulus of 2z minus 1 is equal to modulus of z minus 1. So how can we write it? We can write it in this form, that z minus 1 upon 2 common, let us take 2 common, and we have 2 modulus of z minus 1 upon 2 is equal to modulus of z minus 1, which implies that modulus of z minus 1 upon modulus of z minus 1 by 2 is equal to 2. And this is of the form minus z minus modulus of z minus z1 divided by modulus of z minus z2, and it is equal to a number other than 1. So this would represent equation of a circle. If here we had 1, then in that case we would have said that this would be the perpendicular bisector of the line segment joining 1 by 2 and 1. But here it is equal to 1, so we can safely say that it is the equation of a circle. Another example in this, we have been given that z minus bracket 1 plus I bracket close divided by z plus bracket 1 minus I bracket close is pure imaginary. If a complex is pure imaginary, then what is the relationship between this complex number and its conjugate? That this number would be equal to minus of its conjugate. So their sum would be equal to 0. So here this is pure imaginary, so this plus its conjugate would be equal to 0, and when we expand it and solve it, we get the very neat equation z bar is equal to 2. Now z bar is equal to modulus of z square, which is equal to x square plus y square. So the equation of the circle is x square plus y square is equal to 2. That is, here the answer is a circle. Now let us derive the diametric form of equation of a circle. Now in a circle, what are the main properties? Suppose diametric form means we have been given the coordinates of diameter of a circle, which are say z1 and z2 in this case, and we have to find the equation of the circle with z1 z2 as the diameter. Now what would be the center of this circle? Center would be z1 plus z2 by 2, because AC is half of AB and C is the middle point of A and B. Now we can find the equation using 3 different methods. We will get 3 different formulations, but when we solve them, the equation would be same. First method is here, that we know that this is the radius of the equation, this is also the radius, and this is also the radius. So in that case, what is this distance? This is modulus of z minus z1 plus z2 divided by 2. And what is distance between this and this? z1 minus z2. So this half of that distance is z1 minus z2 upon 2. So what do we get? Modulus of z, that is Cp is equal to half of AB. Putting this values in we get, what do we get? Modulus of z minus z1 plus z2 upon 2, that is P minus C, the coordinates of P, that is z minus this modulus is equal to z1 minus z2 divided by 2, because z1 minus z2 is the diameter here. Now another thing is, what we know, AP and PB are perpendicular to each other. Since they are perpendicular, then their sum of their complex slope would be equal to 0. Again, I would like to remind students that in case of perpendicular, the complex slopes are multiplication of complex slope is not equal to -1, but if the slopes are say omega 1 and omega 2, where omega 1 and omega 2 are complex numbers representing the slope, then omega 1 plus omega 2 is equal to 0. Now what is a complex slope of this line? Z minus z1 divided by z bar minus z1 bar. And what is the complex slope of this? W2 is z minus z2 divided by z minus z2 bar. So when we sum these two complex slopes, what do we get? 0. So this is another equation. Now third method is that AP square plus PB square is equal to AB square. Now here AB is Z2 minus Z1 and AP is Z minus Z1 and PB is Z1 Z minus Z2, modulus of these numbers. So what do we get? We get modulus of Z minus Z1 square plus modulus of Z minus Z2 square is equal to Z1 minus Z2 square. So if we expand these three by putting Z is equal to X plus IY and Z1 is equal to X1 plus IY1 and Z2 is equal to X2 plus I2Y2, we will get the same result from all these three equations. Some students may say, what is the need of going into the proof, because in exam proofs are not going to come? Yes, proofs are not going to come, but when we do this proof and when we write it in detail and go into the reasons, we learn a lot, and the principles which we learn, those principles are going to help in solving different kind of problems. Now let us consider a question on diametric form of equation of circle in complex plane. Now here Z1 has been given as 6 plus I, Z2 has been given as 4 minus 3I, where Z is a complex number such that argument of Z minus Z1 upon Z2 minus Z is equal to pi by 2. We know whenever argument of this type of formation is equal to constant, say an angle alpha, which is between 0 to pi, in all such cases the result is a circle. So here let us start this problem by saying that argument of Z minus Z1 upon Z2 minus Z is equal to pi by 2. What does it mean? It means, if we see in this diagram, that if this angle is pi by 2, Z1 and Z2 are these 2 points, and this is kind of a semicircle, then what does it mean? Then since this angle is pi by 2 and these three are concyclic points, then this angle would be pi. What does it mean? It means that line joining Z1 and Z2 would be the diameter of circle having Z1, Z and Z2 as the concyclic points. Now, since these are the Z1 and Z2 represents the diameter of the circle, given circle, so we can say that Z1 plus Z2 by 2 would be the center of the circle. So here Z1, Z and Z2 are the diameter, so center Z0 is Z1 plus Z2 upon 2. Now all we have to do is find the radius. Once we have found Z1 and Z2 are given, so we know Z0 would be 5 minus I, and what is the radius? We take its distance from any of the Z1 or Z2, it would be same, and it would be modulus of Z1 minus Z2 Z0, and so radius is equal to modulus of 1 plus 2I, that is root 5. So the equation we get is modulus of Z minus Z0, that is modulus of Z minus 5 minus I is equal to root 5. So this B option is correct here. Now let us consider another very important topic for the purpose of JEE. It is equation of circle in complex plane which is passing through three non-collinear points whose coordinates are given as z1, z2, z3. Now we know that we can always draw a circle from three points here, z1, z2, z3. We can always draw a circle from these 3 points. We have to draw the perpendicular bisector of z1, z3 and perpendicular bisector of z2, z3, and we will get the center of circle, and we from there, if we draw a circle from that center with the OZ1, OZ2, OZ3, any of the distance, we will get a circle. So we know from the geometry that from 3 points we can always draw a circle as long as these 3 points are not collinear. Now we have to find the equation of such a circle whose 3 points are given as z1, z2, z3. So let the fourth point is P. And we know that in a circle, if these are 2 points, then ACP is equal to ABP. This angle is same as this one. So what can we say that by using the rotation theorem? What can we say that in this case Z minus let us apply it for the Z2 first. Z minus z2 divided by z1 minus z2 is equal to e to the power I alpha. Here the sign should be z1 minus z2. This is a typographical error. So similarly for using rotation theorem in this for this particular ACP, what do we get? Z minus z3 upon z1 minus z3 is equal to lambda 2 e to the power I alpha. Here lambda 1 is modulus of this number and lambda 2 is modulus of this number. We are just showing lambda 1, lambda 2 to say that these numbers are constants and not dependent. These are not real numbers. That is what we intend to show by writing lambda 1 and lambda 2. Now since you're dividing 1 by 2, what do we get? We get z minus z2 upon z1 minus z2 multiplied by z1 minus 3 upon z minus z3 is equal to lambda 1 upon lambda 2. So which is a purely real number, because these two are modulus. Modulus is always going to be a real number. E to the power I alpha cancels out here. Now what does it mean when this particular expression is real? It means that this more complex number will be equal to its modulus, and distributing the modulus we get this particular answer, z minus z2 upon z minus z3 multiplied by z1 minus z3 upon z1 minus z2 is equal to z bar minus z2 bar divided by z bar minus z3 multiplied by z1 bar minus z3 bar divided by z1 bar minus z2 bar. This is the required equation of the circle. Okay, now let us take a very beautiful question on the above concept. Here z1, z2, z3 are given, and we have been asked to find relation between the arguments of z3 upon z2 and z3 minus z1 divided by z2 minus z1. Now where do we start? If z1, z2, z3, if z1, z2, z3 are given as 3 points, then we can use rotation formula, and what do we get? That argument of if the angle between them is say phi, then what do we get? Argument of z1, z2 minus z1 divided by z3 minus z1 is equal to phi, nothing more. And how do we get to prove this kind of relationship? Now here we have to remember a very important point which would be used in these questions, and I have seen this pattern emerging in many questions. That is that if modulus of z1 is equal to modulus of z2 is equal to modulus of z3, which is in this case, and they all are equal to root 13, then what would be the case if this is equal to this equal to, and these are equal to if all are same, in that case what would mean that anyway with these 3 points a circle would always pass through. But if their modulus are equal, then in such case the center of circle would be origin, because what is this OZ3 is modulus of Z3, this is OZ2 is modulus of Z2, OZ1 is modulus of Z1. If they are equal, means O is the center. So in all cases where Z1, Z2, Z3 are given and their modulus are equal, then the circle passing through these points will have origin as the center. This is a very important concept. The first thing you should have a look in all such question when these 3 points are given is whether their modulus are equal, and if they are equal, then we have to say that their center is origin. So here, as Z1 and Z2, Z3 all modulus are equal and equal to √3, the center is origin, and this distance, this is the radius of the circle passing through Z1, Z2, Z3. Now once we have done this thing, then rest is very simple now, because this is origin, so we can say that this particular angle would be double this particular angle, and applying the argument formula on this particular angle and this particular angle, we will get the result. So this phi would be argument of Z2 minus argument of Z3 minus Z1 divided by Z2 minus Z1, if we take this as the clockwise direction, and this is equal, this angle is half of this angle, which would be obtained by Z3 minus 0 divided by Z2 minus 0. So we get the solution as here. So we get argument of Z3 upon Z2 is equal to 2 argument of Z3 minus Z1 divided by Z2 minus Z1. So our third option is correct. Now I would like to bring to your notice a very important note. Suppose here Z1 and Z2 are any 2 points on complex plane, and Z is another point, variable point, whose locus we have to find. And if it is given that argument of Z moves in such a way that argument of Z minus Z1 upon Z minus Z2 is equal to alpha, then in where alpha is the element of 0 and pi, not including 0 and pi, then in all such cases the locus of Z would be a circle. Then Z would be a circle, and it would be the now here the main thing to note is that here argument of Z, applying the rotation formula, what do we get? Z1 minus Z divided by Z2 minus Z argument, if it is given as alpha, then it is moving like this, that here also this angle is alpha. So since all angles are same, so we can say that this is forming a circle, and whether it is forming the bigger circle or the smaller circle, it would depend upon the fact that whether this alpha is less than pi by 2 or it is more than pi by 2. If it is less than pi by 2, in that case it would be major arc, and if it is more than pi by 2, then it would be tracing the minor arc. So on this particular fact also there will be questions, and I will be explaining one or two in our next lecture. Now our next topic is equation of a parabola in complex plane. See, we have already covered more than 1.10 hours in this lecture, so you may be feeling exhausted and may feel that now this is not an important topic, and I am telling you all these things for the sake of completion. No, it is absolutely not that. The equation of parabola, hyperbola and ellipse are equally important. There have been questions on this, and these concepts must be understood for the sake of doing questions based on these concepts which have come in previous year. So please bear with me for another 15-20 minutes in which I will wrap this lecture. This has been very big lecture, I understand, but if you want to relax, you pause the video and relax, but do view this lecture completely, because this is very important. Now, in case of parabola, suppose we are given the equation of a directrix a alpha bar z plus alpha z bar plus b is equal to 0, that is this line, and focus coordinate of focus are also given as z0, and we have to find the focus of a point P with coordinate z which moves in such a way that its distance from this focus and this line is always constant. That is as per the definition of parabola. So it would, what would it mean? That PS, that is modulus of z minus z0, is equal to PM. And what is the formula for distance of a complex number from a line whose equation is given? We have to just put z here and divide it by 2 alpha. So it would be modulus of alpha bar z plus alpha z bar plus b, modulus close, divided by 2 of modulus of alpha. Now this has to be equal to z modulus of z minus z0. So this is our equation of parabola. Now if we are given that, we know that equation of parabola which is opening in this direction, what is that? Y square is equal to 4ax. Now how do we write that equation in the form of z and z bar? Now here we have written it, we have started with the answer z minus z bar square plus 8az plus z bar, but I would suggest that you start with y square is equal to 4ax, and what do we replace y with? We replace y with z minus z bar divided by 2 and x with z plus z bar divided by 2. So if we put these two values in this, we will get this equation. So if tomorrow if we get x square is equal to 4ay and we are required to find the equation in this form in some problem, so we replace x and value of x and y in terms of z and z bar to get the desired equation. Next is even more important topic, that is equation of ellipse in complex plane. Now here the definition of ellipse, remember in coordinate geometry it took us hell lot of effort in terms of number of steps to prove the equation of ellipse to be x square upon a square plus y square plus divided by b square is equal to 1. But here the definition would come out in one single step. That is the beauty of complex variable and complex plane. Now we know that in case of ellipse, the definition of ellipse is that it's equation of a point which moves in such a way that its distance, sum of its distance from 2 points is constant. Here these 2 points are called focus S1 and S2, whose coordinates are given as Z1 and Z2, and P moves in such a way that PS1 plus PS2 is equal to constant. Now PS1 is modulus of Z minus Z1 and PS2 is modulus of Z minus Z2. So sum of them is constant. So what do we get as equation of ellipse? We get modulus of Z minus Z1 plus Z minus Z2 is equal to K. Here K should be greater than equal to Z1 minus Z2. Then locus of Z represents an ellipse whose foci are Z1 and Z2. If K is equal to Z1 my modulus of Z1 minus Z2, if the difference between them is equal to modulus of Z1 minus Z2, then this would become a straight line. The P will trace a straight line and not an ellipse. You can also check this fact. It's a very simple but very important fact. Whenever we are given a question of this formation, modulus of z minus z1 plus modulus of z minus z2 is equal to k, the first thing we will do before assuming it to represent ellipse is that we will check whether z modulus of z1 minus z2 is equal to k, and if that is the case, then we have to assume it to be equal to then we will have to assume that the locus of P would be a straight line. Here, if k is equal to z modulus of z1 minus z2, then locus of z is a line segment joining z1 and z2. So here, this is the diagram for the same. Now let us take a very standard problem on the equation of ellipse in complex plane. Here, modulus of z minus 1 plus modulus of z plus 3 is being given to be less than equal to 8. So what is the value of z1 here? It is 1. And what is the values of z2? It is minus 3, because in the equation it was modulus of z minus z1 plus modulus of z minus z2 is equal to 8. Now since here we are saying it is less than equal to, it means all points lying inside this ellipse with focus as 1 and minus 3. So minus 3 is a focus, 1 is a focus, and we have drawn an ellipse like this, and it is less than equal to 8. So 8, what is the 8? 8 is this distance, A dash is the 8. Now what would be the center of this ellipse? Since the focuses are given as minus 3 and 1, and center is how in middle point of these two, then it would be minus 3 plus 1, that is minus 2, divided by 2, that is equal to minus 1. So now we have the center, and we know that this distance is 4 and this distance is 4. So if this point is minus 1, this would become on adding we will get 3 0 as the coordinates of A. And what are the coordinates of A dash? The coordinates of A dash would become minus 5, because here we have to subtract minus 4, because so origin would be somewhere here, and this distance would be 3 0 3. So coordinates of A are 3 0 and coordinates of A dash are minus 5 0. So now we have been asked to find the range of values of modulus of z minus 4. So what is 0.4? 0.4 is this is 4 0. And what is the value of, what is modulus of z minus 4? Z is a point some on the ellipse, anywhere on the ellipse or inside it. It may be here, it may be here. So all these points. And so what are the values? Now in all such cases, the first thing we do is draw a line joining between the given point and the center, and minimas and maximas would lie on this point, and the minimum distance, as is obvious from this picture of point P, from any of the points inside or on the ellipse is PA, and the maximum is PA dash. So A, we know the A's coordinates we have calculated as 3 0. So AP will become 1, and what is the value of P A dash? This coordinates are minus 5 0 and this is 4 0, so it would be 9. So the range of value would be between 1 and 9. So C is the correct answer. Now how have I said that this minimas and A dash would be the point representing the minimum and maximum distance of P? Because if you draw a line like this rather than a line joining P to the center, if we draw a line like this here, then this line is always this point it is intersecting here, so this distance is greater than this, so it is this distance is not the minimum distance, and this distance is less than this particular distance. So we know that in all such cases we should always draw a line from point P to joining it point P to the center of ellipse. Similarly, we will be getting the maximum of if it was a circle also, then we should we will also be drawing a line joining P to the center of that circle, and this would be the diameter of that circle. So always keep in mind, now such a complex problem, if we don't use this method, then it would be very cumbersome to solve. We have to take different cases and then solve. Now we get the solution in 2 line, but to solve this thing in 2 line and in less than 30 seconds to 1 minute, as is the required now for IIT, we have to have our fundas absolutely clear. We should have done lot of practice, then we would find that this type of questions are very easy. Now let us take another very beautiful example to explain the concept of ellipse in complex plane. Now here modulus of z plus 2 plus modulus of z minus 2 is given as 8. So as always, we will first check whether z1 minus modulus of z1 minus z2, that is 2 minus 2, that is modulus of 4, whether it is equal to this number, but it is not. 4 is not equal to 8, so this would be representing ellipse. So here it is equal to sign, so z would represent all the points on an ellipse with focus minus 2 and plus 2, and the point, since it is minus 2 and plus 2, the center would be origin, and minus 4 and 4 would be the vertices. Here minus 4 and 4 would be the vertices. Now the second equation is being given as modulus of z minus 6 plus modulus of z plus 6 is equal to 12. Now here what is the value of modulus of z1 minus z2? It is 6 minus 6, that is modulus of 12, that is 12, and which is equal to 12. So this would represent a straight line. So a straight line segment between minus 6 to 6, as we had explained in the theory. So between minus 6 to 6, this line would meet it at the vertices, that is minus 4 and 4. So the correct answers are 4 and minus 4. See, without even writing a single word orally, we could solve the problem, just because we have our fundas absolutely clear here. Finally, we have come to the end of this very long but very important lecture for JEE as far as complex number is concerned. Now here we have to find the equation of hyperbola in complex plane. We know that in case of hyperbola, the point PZ moves in such a way that its difference from 2 points, which are the foci of that hyperbola, is always constant. So the difference is z of this distance is ps, which is modulus of z minus z2, and this is modulus of z minus 1 z1. So difference of these two distance has to be constant. It means that the equation of the hyperbola would become modulus of difference between the modulus of z minus z1 and z minus z2. If this distance is constant, then we will get the hyperbola. But here again the same old condition, that if k is equal to modulus of z1 minus z2, then in that case pz would lie on the rays emanating either from z1 or z2, that is this ray or this particular ray. In case of hyperbola, in case of ellipse, if z1 minus z2 was equal to k, then we said that z would lie on the line segment joining z1 z2. But in case of hyperbola, it has to be the other way around, that z would lie on anywhere on this line anywhere but on the line joining S1 S2, but on rays emanating from S1 and S2. So these two would be the areas where the Z would lie if modulus of Z1 minus Z2 is equal to K here. So for as in case of ellipse, whenever we are given such a problem, the first thing we will check is whether modulus of Z1 minus Z2 is equal to K or not. Now with this we conclude this lecture, and in next lectures we will be doing lot of examples based first on this, and then geographical representation of complex number, and then on various other topics. This in all these 5-6 lectures we have essentially covered the theory part, and the examples were to expand the theory. Now the examples which we will be taking, those examples would either enhance our understanding of a concept, explain the different ways a concept can be used, and or oblique, or they will help us get some tricks which we can straight away apply. So if the 30-40 problems which we would be doing now in examples, if you do that and do lot of practice to master those techniques, I think we will have covered a very big distance, and it would really help you in getting success. Our effort is to provide a comprehensive resource starting from basic lecture to practice problem to examples and videos of examples. Now you would also appreciate this thing that if we try to do it in a more animated manner, or using animation on drama like some other websites do, then we will not go into the depth of the subject which is required for an exam like JEE. For 11th 12th, yes, because the syllabus is less, so you can do lot of drama, graphics, this and that, but for in-depth study for an exam like JEE, you have to cover lot of distance, and if we start making animation, it would take us years to make animation for this much material. So I hope you understand that depth of content, quality of content is more important and than the simple drama which many of our competitors do. Thank you.